Welcome in the arena. My name's Allison Klein. We're coming to you from the OCP Summit in San Jose. And I am so glad because Carl Schlachte, CEO of Ventiva, is back in the TechArena studio with us. Welcome back.
Glad to be here. Good to be back.
So, Carl, you were recently on the program discussing your innovative cooling solutions, and we were talking all about, laptops and different types of device deployments. And here you are at OCP Summit. So I have to ask, that seems like news in itself. What does this mean for the data center?
I think what it means for the data center for us is that the activity that we put into designing cooling for laptops is directly applicable to all the stuff that you can look at in servers. So to just give you some real quick metrics, power density in a laptop is actually higher than power density in a server.
That's a good data point.
Yeah, it's the reason is physics. You're talking about a much more constrained space with higher compute values as opposed to a server. So in a server, one U rack, for example, might be something on the order of 90 liters worth of space, or not, I'm sorry, 12 liters worth of space. On a laptop, that's more like 3 liters worth of space, if not a little bit smaller, depending on the size of the laptop. Yet the compute density tries to approach the same level. And the result of that is everything that we've learned in laptops is directly applicable to the stuff that you can do in servers. And that has some pretty concrete benefits for a server.
Now, it's very timely that you bring this up because we're hearing all about the cooling challenges at OCP Summit this week. Rack designs cresting beyond, a megawatt and facilities beyond a gigawatt. Can you describe how this challenge offers an opportunity for Ventiva to step in?
Sure. So I guess the easiest way to think about this is like a 1U server rack. So a 1U server rack is roughly, as I just mentioned, 12 liters worth of space. In that 12 liters worth of space in implementations today, actually only 3 liters of that is compute equipment. The rest is space. And the reason the rest is space, that other 9 liters of space, is in order to allow airflow through the system to get rid of all of that heat. And the part of that challenge is, or the part of the reason that is that way, is that fans really, if you look at it, if you remember what a fan looks like, just a square box with pushing air in one direction, what you're doing is you're actually moving as much air as you can through that server in order to be able to get cooling. And you want to do everything in a nice straight line. You don't want turns, you don't want baffles, you don't want any of those things. The challenge is, as processing power and the kind of data points you're giving go up, you get to a point where you actually can't move enough air in order to cool the thing, right? So you start to see things like cold plates show up and things like that. Okay, so wouldn't it be great if you could actually just put cooling right where the heat is?
Okay, yeah.
And that's where we show up.
Okay, so, I know that we've been talking a lot with a lot of vendors about liquid cooling solutions for the data center. They're talking about direct to chip. They're talking about immersion. They're talking about rear door heat exchangers. But where do you see the move for more innovation?
Well, so I would say, speaking as an engineer, the first thing you want to do is use what you already have rather than try to create something new that requires all sorts of challenges with it. So if we just take an existing rack and we say that we can get rid of some of the fans that are existing in that system by replacing them with a device this is our device. That's an air mover.
It looks almost like a harmonica.
Yeah, it is. It kind of looks like a small harmonica, completely solid state, no moving parts. This will move between 1 and 2 CFM of air. If you could put this directly where the heat is occurring in a server, what you end up with is a reduction in power needs. About 15% of a server's actual power budget, the total server, is devoted to cooling. Devoted specifically to the fan, actually. So we've done a lot of work working with some server folks on this, and if you just go with directly implementing cooling where the heat problem is, and you remove some of those fans that are existing in there, you can get a reduction of anywhere from 4 to 5% of the overall power budget for a server. Now that sounds like a small amount in general.
It's huge.
It's actually turns out to be huge. So if you do the math, with just deployments that exist right now in the United States, just talking the United States. And everybody just did what we said you can do with this, right? You place all the servers with this. That's 3 Hoover dams worth of power.
Oh, wow.
Or 750,000 homes
That's
per
crazy.
year
Yeah.
savings. And you're not changing the square footage of the box at all.